Yay, finally. All right, so here we go. Mini review, we're taking a deeper look. It says, example 1, find all angles between 0 and 720 degrees that solve the following equation. And it says sine theta equals a half. And I chose that on purpose, guys. I did that because I know this is something that we all know when it comes to the unit circle. So I'm drawing a unit circle here. It's not perfect unit circle. And I know that the sine is the y values. So the y values are a half at this horizontal line. Notice that I drew, what is that horizontal line? That's y equals a half. I have a coordinate and I have a coordinate. And it happens there and it happens there. And the reference angle on both of those is 30 degrees. So before we would say 180 minus 30, and that's how we got the 150. So that's what we're gonna do. So how would we do this? So here's how we would do it, guys. So we would get theta by itself, and we do that by taking arc sine of half. By the way, I was in your physics class earlier, maybe not, it was that last week. And some of you guys were calling that sine to the -1. Don't call it that. It's either called arc sine or inverse sine. Inverse sine. I don't think I spelled inverse correctly. Inverse sine. Okay, now you see this plus 360n? That is because if I'm right here, let me write it in red. This angle there is 30 degrees, and if I go another 360, that's gonna put me there, back at that location. Do you guys agree?
Yes.
Yeah. So if I do arc sine in the calculator, that's only gonna give me 30 degrees. So this is what you call a general equation. General equation is theta 1 equals 30 plus 360n, and you put a little degree symbol there. Now, how do I get the second one? Because I know the second one is 150. Now, if you know that for a fact, you can just write 150. But how do I get it from what I know? Well, remember that when I type in arc sine of half in the calculator, it's going to give me 30 degrees. So let's see if we can come up with an equation. 180 minus arc sine of half, that will give me the 150 plus 360n. See this right here, where you see that little bracket, that will give me the 150 degrees. Because arc sine of half, the calculator is going to give me 30 degrees there. The calculator is not going to give me 150. So I'll show you what I mean. Let me go ahead and share my Desmos. So I'm going to share. And at the moment, it's not on Desmos, but it will be. Desmos. How fast? Let's see. Okay, it looks like it's working pretty good today. I want a scientific calculator. So now if I click arc sine, so here we go, arc sine, and if I type in a half, this Desmos gives me 30. And of course, we said it in the past that that's your reference angle, and that is true. And if you know that the y value is a half, and you know that that happens in quadrant 1 and quadrant 2, you can just do 180 minus 30, and that will get you the 150. See, so if I type down here in the front 180 minus that gives me my 150 there. See, so why am I trying to tell you guys? Why am I changing the focus into these equations? Because in the future, we're gonna have contextual questions, and you're not gonna be asking yourself like, oh, in what quadrant is it negative? In what quadrant is it positive? You could still do it that way, but in the future, you're gonna be faster if you just write equations. So it says, what are my general equations? So if you have something like this, so in essence, if you have something like sine theta equals some y value or some value, if you want all solutions, if you want all solutions, then here you go. Theta 1 is just whatever arc sine of y, and then you just do another revolution where n is an integer, and then theta 2, you're going to do 180 minus arc sine of y, and then whatever that is, you're going to keep adding a revolution. Semicolon, where n is an integer. Did that make sense to you guys?
Yes.
Okay. All right. So now let's talk about the cosine. The cosine is actually pretty easy. It's actually, you're going to like it. At least first period liked cosine better than sine. So for cosine, I want you to notice it on the unit circle. Where is cosine a half? Cosine is a half there at 60 degrees and here at, what's that, 300 degrees. Now the reference angle again is still 60 degrees. But if I do this, so obviously this is a reference angle of 60 degrees, but if I count from the horizontal axis, I can say that's negative 60. So I can rewrite this in the general form, and I can say this, guys. Oh, by the way, I didn't even answer the question up here, right? Darn it. Okay, let's stick to this one first, and then we'll talk about the top one on the top. I can write plus minus arc cosine of half plus 360n. Why will that work? Okay, so let's go ahead and label theta 1 all the positive angles, all the ones with the positive. And I'm going to label theta 2 all the ones with the negative. So if I type arc cosine a half, the calculator is going to give me 60 degrees. So I'm going to write 60 plus 360n. If I use the one with the negative, I'm going to write negative 60 plus 360n. Now let's see if I can get all the answers between 0 and 720 degrees. So the very first one, I'm going to go in order from the smallest to biggest. The very first one it's going to give me is going to give me 60 degrees. The next one is going to come from theta 2, and it's going to be at 300 degrees. The next one's going to be from the 60, or from theta 1. It's going to be the 60 plus the 360. And don't worry, we're going to prove this, guys. What's 60 plus 360? 36, is that 42? 420 degrees. And then the next one's going to come from the 300 plus 360, 36, that's 660. And if I keep adding another 360, I'm done. That's it. Now, where did all these come from? That came from theta 1. That one came from theta 2. That came from theta 1. That came from theta 2. Now, what am I talking about? Chavez, you're losing me, and I have no idea what you just did. All I did was this formula right here with the plus minus, and I toggled it. Let me show you what I'm talking about. I'm going to go to Desmos. So I'm going to go to Desmos. And remember, if I type in arc cosine, the Desmos is, I mean, it's not necessarily dumb. It just doesn't know where you're at, whether you're in quadrant 1 or in quadrant 4 for arc cosine of half. So if I type in arc cosine and I type in a half, look what it tells me. It tells me 60 degrees. But if I add another 360, well, if I add another 360, I'm still in quadrant 1, guys. Oh, I got to go up here, huh? You know what? I'm going to say that's A. A equals that. A equals. And then I can just go A plus that. So if I go A plus that, look, it gives me 420. When am I ever going to get the ones in quadrant 4? You're not. You're not. So how do you get those? By making this angle negative, plus or minus. So look, if I put a negative in front of that, check it out. Where are you, buddy? Negative. Look. 300, and 300 degrees is one of my answers. So is this starting to make sense, guys?
Yes, sir. Mm-hmm.
Okay, so now look, I want you guys to see that all these answers that I have will give me a half. So look, check it out. I'm going to clear everything, and now I'm just going to write cosine 60, enter. It gives me a half. And I'm going to write cosine 300, which is an answer that I got, and it gives me a half. And I'm going to write, what's the next answer that I had? Cosine 420, and it gives me a half. And the next one was cosine 660, and it gives me a half. See, it works, guys. All of these angles are solutions. So what am I going to do from now on? Well, not always, not for now. If you still want to go the reference route, you can still do the reference route. But if you want to, if you care about speed, if you want to be super fast, all you got to know is the little tricks. Plus minus for cosine when you're doing the inverse, and for the sine, it's the original, and then 180 minus the arc sine. See, and there it is, guys. So what are my general equations? If you have something like cosine some angle equals some x coordinate of some ratio, to get all solutions, you're going to do theta equals inverse cosine or arc cosine, that's how you call this, plus 360n. Plus minus, sorry. Plus minus in the front. That's the key. That's the key. The cosine has the plus minus, or the arc cosine, and the inverse is two separate equations. One arc sine of whatever, and then 180 minus arc sine. Is that starting to make sense, guys? Is that a yes?
Yes, child.
Okay, okay. Hey, be nice. Be happy, guys. Be happy. I want you guys to be happy. I want your cats and dogs
I
to
didn't
be.
mean to sound rude. I'm sorry.
No, no, you're good, miss. You're good. Make sure your cat is happy, though.
Yeah.
All right, let's see. What else do we got here? Oh, n is just how many revolutions we've done. So 360, so if I've done one revolution, you put a 1 in there. If you've done 2 revolutions, you put a 2. If you've gone negative, like if you went clockwise, you put -1 for -1 revolution. So n is just how many revolutions. All right, like here's another one, guys, and I did this one on purpose. I put a negative angle. So you can see, even if you were to do these formulas blindly, you will still get the same answer. So what did I have for formulas last time? We said sine of some angle equals some value y. We said to do this. For theta 1, it would just be arc sine of y plus 360n. And then we said for theta 2, it was 180 minus arc sine of y plus 360n. Even if we just follow blindly, we'll get the answer. We already know. We know these answers, by the way. So look, arc sine in the unit circle, where does this happen? That it's negative there and there. So we know that the answer is going to be 240 and 300. So let's see if we get those answers. Theta 1, arc sine of negative square root of 3 over 2 plus 360n. Theta 2, 180 minus arc sine negative square root of 3 over 2 plus 360n. And I just remembered right now, guys, we didn't even answer the question number 1. So we'll go over there in a little bit and answer them. All right, let's try this out. Check it out. And in a moment, at the moment, since we haven't studied how to graph sine and cosine, you probably don't know something called principal branch, especially for inverse functions. So that's okay for now. That's okay. We're going to talk about it when we get there. We're not there yet. Now check it out. I'm going to do arc sine. I'm going to type in negative square root of 3 divided by 2. And look, it actually does give me a correct answer. Negative 60 degrees is in quadrant 4. That is one of the solutions. But my domain is between 0 and 720. So that can't be it. Does that make sense? But if I add 360 to it, I'm going to go plus 360. Look at that. 300 is an answer. That's definitely an answer. You know what? I'm going to call all this A, guys. So I'm going to delete this just to make my life simpler. I'm going to do this. Look, I want this to equal A. I'm going to put equals A. No. I guess I got to put it over here on this side. A equals. A equals. All right, so there it is. There's my A. And what am I going to do? I'm going to do A plus 360. Hold on, guys. A plus 360. There's one answer. Write that down. Write that 300 down. Okay, what's another answer? Well, let's add another 360. So I'm just going to multiply by 2. So 660 is another answer. If I put 3, I go outside my domain, and that's it. Yep, that's way too big. All right, I'm going to clear all this. Since I already called A equal to this, what did I say we could also do? I said we could also do 180 minus A. 180 minus A. So look, 240, that's another answer, right? So there it is. We're back in business. So 240 is another answer. That's if n equals 0. And then I'm going to go plus 360. So write that number down, 600. And if I do another one of those, I think I'm already outside. So yeah. So now it's too many. That's 960. 960 is a no-no because it has to be between 0 and 720. So do you guys remember all the answers that you guys got?
Yes.
Okay, let me write the answers down first. Give it to me from smallest to largest. It was 240, And then it was what?
300, I think.
300. And then it was
600.
600. And then finally it was it 660?
Yes.
And was that it? Hmm.
Yes.
All right. And then let me see if I remember correctly. Did we get the 300 from theta 2? Yes. And I think the 240 came from theta 1. And then this one came from theta 1 with the 240 plus 360. And then this one came from theta 2. All right. Now I'm going to test them all. Check it out. I'm going to go to my Desmos. And I'm going to test them all. So I'm going to clear everything. And I'm going to find out what the square root of 3 over 2 is. Negative square root of 3 over 2 in decimal. So negative square root of 3 divided by 2. So this is what I'm looking for. I'm looking for that negative 0.866. So now check this out, guys. Sine. Give it to me in order. What was the first one? 240? 240. Look at that. Sine. The next one was 300. We already know those. And look at that. The next one was, what was the next one? 600. Look at that. Beautiful. Just beautiful. And then the last one was, what was it? 660. And look at that, guys. All of them were the same. You guys don't think that's beautiful?
So, sorry. It's beautiful, Joe. So we have to use both types or both equations for theta 1 and theta 2 regardless, right? Like
Yes.
we don't pick and choose.
Correct. We have to use theta 1 and theta 2 to get both. I did this one on purpose. I wanted you to see that it works. Yes, if I know what you're thinking. A lot of you are saying, man, Chavez, this to me seems harder. Why can't I just go back to the route where I just find the reference angle and call that a positive angle and find my reference? And then I know sine is negative in quadrant 3 and quadrant 4, and then do it that way. Yes, you can do it that way at all. You can do it any way you want. But when we start doing word problems, if you want to be fast, this is the way that you should do it. I'm not saying you have to do it this way, guys. You can still do, even when we have word problems, contextual problems, you can still do it this way if you know the logic. If you say, well, I know that I better be getting a negative answer, and I'm going to start thinking, well, in the unit circle, y is negative in quadrant 3 and in quadrant 4, so let me go ahead and put them in quadrant 3 and 4. Yes, all that will still work. But if you don't want to use a lot of brain power, if you want to be fast, this will always work. Does that make sense, guys? Uh-oh.
Yes. Yes.
Okay. All right, so check it out. Look, we already know that cosine is negative in quadrant 2 and 3. But let's see if we can do this with the minimal brain power. Oh, okay, Chavez told me that if I get theta by itself, theta equals arc cosine. I just got to put plus minus in the front because it says cosine. And then whatever it is on the inside, square root of 3 over 2 plus 360n. So that's what Chavez told me. So when I type this into the calculator, arc cosine of negative square root of 3 over 2, let's see what it gives me. Oh, I was about to rewrite the whole thing again. So let me write that into my Desmos here. So let's go to Desmos. And I'm going to go arc cosine. So let me clear everything. So I'm going to go function, arc cosine. And I'm going to go negative square root of 3. And I'm going to divide that by 2. And there it is, 150. And that's actually one of my real answers. So I'm going to go back. And I'm going to push plus minus 150 plus 360n. And then I'm going to start giving my answers here. Theta equals, if you want to break it up into two of them, but for one for the positive, one for the negative, you can. So one answer is definitely 150 degrees. The other answer would be the negative 150 plus 360. So negative 150 plus 360, I'm going to take my little calculator here on the side, plus 360, that is 210. We already knew that. And then you're going to just keep going. 150 plus 360, 510. And then 210 plus 360, 570. And I think that's it. If I take 510 and I add 360, I'm above the domain. So all of these answers will give me negative square root of 3 over 2. If I go to Desmos, so again, so here we go, guys. Here's Desmos. We already know what square root of 3 over 2 is because we did it a little while ago, but we'll do it just in case. Just in case you don't believe. So there it is. So let's try it. Cosine 150, enter. Look at that. We already know that. Cosine 210, enter. Look at that. Then we had cosine, what else do we have, Harris? 510? 510, bam, look at that, guys. Cosine, what was the next one? 570. Look at that, beautiful, guys. All of them are the same. Yay. Now, you don't have to do this route. You don't have to memorize anything. If you want to continue to do it with your reference angle, that is perfectly acceptable. But I think this route is going to allow you to be super fast. Minimal brain activity. You just memorize a few little things. And I'm not trying to tell you to be a robot, but because that's what I want. I don't want robots. But if you understand the concept, then you know you can just take all these shortcuts because this is coming from the concept. Chavez, I don't understand how it's coming from the concept. Let me explain. 150 degrees is from here to here. That's 150. And I know that at that coordinate, my x coordinate is negative square root of 3 over 2. My y is a half there. I know that it's also negative square root of 3 over 2 right here. And check it out. Do you agree? Does everyone agree that this is also 150 degrees, but in the negative direction? Do you guys agree there? Yeah, that says negative 150. Do you guys agree that that's negative 150 degrees?
Yes.
Yeah, negative half. Yeah. So that's why it works, guys. What's up?
What is the n after the 360? I think so.
The
I
n,
think Faith asked
the
it
n just stands for
earlier.
revolutions. The n stands for, it's an integer, and it just means like how many revolutions have you done. So if I'm here at this blue one and I do 2 n's, or let's just do 1 n. So if you see that right there in blue, that's a whole revolution. That is 360 degrees. So the n just stands for how many more cycles have you done? How many more revolutions have you done?
Oh, is that why we're adding? Oh, is that why we're adding 360? So like we're
Yeah.
like, okay. Thank you, sir.
No, it's all goodness.
So we don't like multiply anything by 360, right? It's just kind of there to like remind us that it's the revolution.
Yeah, you don't know. You can just, whatever answer you get, you can just keep adding 360 and 360 and 360. Unless unless I tell you like, give me 3 iterations worse. So then you're going to go 360 times 3 plus whatever you get. But no, you can just keep adding 360. That's all. Cool or not cool? Guys, okay. All right, now this is the easiest one. You're going to love this one. But there's nothing to memorize on this one. So arctan of 1. So I'm going to draw the unit circle first so everyone can understand this. So tangent is 1 in quadrant 1 and in quadrant 3. In quadrant 1, that is square root of 2 over 2, square root of 2 over 2.
Okay. My camera's off. They can't see you.
You can't see? In quadrant 1 or quadrant 3. That's the only time that that tangent is 1, because remember, tangent is y divided by x. Now, look at this. Look how simple this is. Everyone knows that this is 45 degrees, I hope. I hope everyone knows that. So if I go theta equals arctan, or inverse tan, of 1 plus some number, we're going to figure out what that number is. This right here, the calculator is going to give me 45 degrees. Try and think. So how do I get the other one? Someone tell me, what is this amount from here to here? That in blue. Or I guess I should write it in green because I already have something in blue there. So what is this amount in green? Like what is that in, how many degrees is that? Just in green.
180.
Yeah, that's all it is. That's all it is, just 180. and I can just keep adding 180 over and over again to get all my answers. So since I want all my answers between 0 and 720, I can just keep adding 180. That's all. That's it, guys. So look, 45 plus 180. So that's 225. So here are my answers. Theta equals 45 degrees, comma, if I add 180, I get 225, comma, if I add another 180, I get 405, comma, if I add another 180, I get 585. If I add another 180, I get 765, and no bueno. I don't want anything bigger than 720. So there it is. And if I go back to Desmos, so check it out. Let's go to Desmos. Desmos, and I'm gonna clear all. So look, this should not be a surprise to anyone. Arctan of 1. This should not be a surprise, 45. Okay, so, and you already got all the answers. So you guys help me out. Let's see, 10, 45. 1, perfect. 10, what was the other one that I got? What was it, 220? 225? 1. 10, what was the other one? After 225, what did I get? 405? 405. Look at that. 1. 10, and then what was it? 505? 505. Oh, let's clear
It was
that one.
85.
It was 585. 1. And then one more. Nope, that's it. And look at that, guys. All of them ones. All of them. And we still, I just remembered that we never answered example 1 over here. So you guys need to remind me, guys. We never answered example 1 ever. We just gave 2 equations. So let's go back to example 1 really fast. Theta equals, let's see, one answer is 30 degrees. The other answer was 150. And then 30 plus 360, that is 390. And then 150 plus 360, that is 510. And all these angles will give us our solution of sine being a half. And I got them. If you're wondering where I got them, here we go. I'm going to label them. Theta 1, theta 2. Theta 1, theta 2. All right, finally. Let's scroll all the way down. My apologies. Please don't give my YouTube channel a thumbs down because I went to problem 1 and then problem 3 over here. So here we go. So tangent is square root of 3. That's actually a perfect coordinate. So remember that tangent is y divided by x. So square root of 3 over 2 divided by a half. So on the unit circle, that happens, let's see, the y over x. That happens here at 60 degrees, and then again there. So I already know the answers. I'm supposed to be getting 60. And then the other one is, let's see, 180 plus 60. Or just knowing, right? 240. Negative divided by negative is a positive. And then keep going. 240 plus 80. Plus 180, sorry. That's 420. And then add another 180. And that's 600. And then if I add another 180 to that, that's 780, and that's out of there, so no bueno. So that one's out. So all of these will give me square root of 3. Let's verify. So I'm going to go to my Desmos. I'm going to first find out what square root of 3 is as a number. So square root of 3, I'm going to push enter. Oh, square root of 3. 1.732, that's what I better get. All right, let's see, 10, 60. 1.732. 10, what was the next one that I put? 10, 240. 1.732. And then I put tan 420. Tan 420. 1.732. Tan 600. 1.732. And if I were to do tan 780, of course I'd get the same one, but I wanted it within the domain. So there it is, guys. All those angles give me a square root of 3 for 10. So I think we're in business. So what is my general equation for tan? So if I have tan theta equals, and I know it's y over x, but I'm just gonna give it some name, like one letter, equals some a to get all the solutions, all solutions. You're gonna go theta equals arctan of a, whatever that is, plus 180 n. That's a degree symbol up there. That's not a, all this is in degrees. Later on, we'll talk about radians. It's probably easy to fix it for radians, but for now, we'll just talk about that. How do we feel? Do we feel okay, guys? Okay, real quick. Everything that we have done, if you want to use the reference angle, that is perfectly fine. As a matter of fact, I'm gonna use the reference angles for these two here because I think it's the easiest route. The only reason that I did not do any of these with reference angles is one, you already know, and two, I wanted you guys to show that these equations are coming from somewhere. So if you pick up a textbook and it has all these solutions or all these formulas, know that they came from somewhere, guys. They just didn't magically appear. All right, so look at these. These are the last two examples or the last three examples or four examples. They're all the same. So here we go. It says, find all angles between 0 and 360 that satisfy the equation below to the nearest tenth of a degree. So now look, this is no longer a perfect coordinate on the unit circle. If you don't even have to think about it as a coordinate on the unit circle, it's a ratio. But here we go, it's cosine. So I know I can find them both by just going cosine equals plus minus arc cosine of negative 5/7 plus 360n. No, you do not have to do that. You can find the reference angle by going arc cosine of 5/7, and you know that cosine is negative in quadrant 2 and 3, and you can do 180 minus reference and 180 plus reference if you don't want to go this route. So here we go. Theta equals, I'm going to do the positive one first. So here we go. I'm going to go at my Desmos. So I get Desmos. And I already forgot what I had in there. I'm going to call it A. A equals arc cosine. I know that much. And what did I have on the inside, Miss Harris? Negative something? Negative 5/7. So there it is, 135.58 plus minus. I labeled it A. So here's what I'm going to do because I labeled it A. Desmos is smart. So that's one answer. So everyone write that. What says nearest 10? So write 135.6. Did everyone do that? I'm going to write A plus 360. There's another answer. Oh, wait. Did they want the answer between 0 and 360?
Yes.
Oh, okay. Then that is not an answer. Let me put a negative in front of the A. There's another answer. So there it is, 224.415. I personally think this is faster than doing the reference. When you do the Delta Math today, it's going to be doing all of them with the reference angle. That is perfectly fine if you want to go that route, but see if you can start practicing doing it this way. So there it is. Those are my two answers, guys. 135.6 and 224.4. So let's see if I remembered that. Oh, man. 135.6 degrees, comma, and I already forgot, 224.4. Okay. The 135 came from the plus. The 224 came from the minus plus 360. I guess I should write it. That came from negative 135.6 degrees plus 360. And no, you do not have to do it that route. You could always just get the reference angle and do 180 minus, 180 plus. All right, here we go. This one here. Sine theta equals negative 2/3. Yes, you can do it with the reference angle. I'm not. I'm just going to go theta 1 equals arc sine of negative 2/3 plus 360n. Theta 2 equals 180 minus arc sine of negative 2/3 plus 360n. And I'm gonna get them all. So here we go. I'm gonna go to my Desmos. I'm gonna clear. And I'm gonna start writing. I'm gonna write A equals, and I'm gonna type in arc sine arc sine, and I had something on the inside. What did I have in the inside again? Negative, was it 2/3?
Yes.
Okay, so there it is. So negative 41.81. I'm going to add 360. I'm going to do that on the next line. So here we go. I'm going to put negative A, and I'm going to go plus 360. Hey, why did I do negative A? That's wrong. That's wrong. That's wrong. That's wrong. I'm going to go A plus 360 because I was thinking it was cosine. There it is. So that's one answer. 318.2. The plus minus is only for cosine, not for sine. So how do I get the other one? Well, the other one I get it like this, guys. Ready? I'm going to delete this plus 360. Did everyone already write the 318.2? I get it like this. I do 180 minus A. So 221.8 is the other one. And there it is, guys. Okay, give me both angles. Give me the smaller one first. Where was it? 221.8. And then the other one was 318.2. Put degree symbols. This one came from theta 2. This one came from theta 1, adding 360 to it. And they're both correct because sine is negative in quadrant 2, in quadrant 3 and quadrant 4. Yes, you can find the reference angle. You don't have to go that route if you don't want to. All right, here we go. Example 6. Angle theta in standard position, negative 4,7 is the point on the terminal side of theta, and I'm between 0 and 360. What is the measure of theta to the nearest tenth of a degree? So you're no longer on the unit circle, guys, because obviously that is not on the circle. So let's see, I have a grid and negative 4,7. So negative 4,7 point. I'm in quadrant 2. And then I'm going to draw a triangle. So here's the origin. So let's see, this distance has to be negative 4. This distance has to be 7. The angle they want is actually this one. That's actually the angle they want. I'm going to do the reference angle. All this talk, right? All this talk about reference angle that I've been saying, don't use it, don't use it. And here I am using it. And the reason why I didn't emphasize the reference angle on all these guys is because there will be a time where speed is more important because we got to get to the problem contextually. You can always do it with logic, but sometimes formulas do help us go fast. Okay, so here we go. And hopefully you've already done this. This is very similar to in physics, like you have a force or you have a speed of 4 in the x direction, negative 4, and you have a speed of 7 in the y direction. What is that angle? It's the same thing. All of it is pretty much the same. So here it is, theta reference. If I want theta reference, that 7 and that 4 is opposite and adjacent. So, ka, toa. If you want to find the hypotenuse, you can. But I would use the 4 and the 7. So which one am I going to use? Sine, cosine, or tangent? Not everyone at the same time.
Tangent.
Yeah, tangent. It's okay to be wrong, guys. If we're wrong, what's the worst that's going to happen? So tangent, opposite over adjacent. 7 over 4. Notice that I put positive numbers instead of negative because I want to find my reference. So theta r is equal to arctan of 7 over 4. And let's see what that gives us. So I'm going to go to Desmos. And I'm going to clear everything. And I'm going to go arctan of 7 over 4. So 60 degrees is my reference. So if I want to know my real angle, I'm going to do 180 minus that answer. I'm going to call it A equals that. A equals 180 minus A. So there it is, guys, 119.7. So I'm going to go back to Desmos. And I already forgot, this was 60 point something. What was it? 60 point? 255, that's fine. And that's not the angle I want. The angle I want is this blue one. So that blue one is 180 minus this guy. And that was short-term memory. Was it 119? I thought it was something else. 119.7. Yeah, you're right. 119 point. There we go. There we go, guys. Yay or nay?
Can you repeat the general equation for the tangent one more time?
Well, I didn't do the general equation for tangent, but if you would have, you could have done this. You could have said arctan of 7 divided by -4, and that's actually going to give you an answer in quadrant 4. And whatever that is, you can just add 180 to it, and I bet you would have gotten the same answer. So I bet you, let's try it out. So let's check it out, guys. This is going to be awesome. Thank you for asking that question, miss, about the general equation. So look at this. Arctan, all this talk, Chavez, about not using reference angles, and here you are using reference. Let's just do the way you did it earlier. Like, okay, let's do that. 7, oh man, look at that. 7 over 4. So look, it gives you quadrant 4 because it doesn't know we're in quadrant 2. So would I take that answer and I just go plus, and I just go 180? And look at that. OMG, look at that. Cool, right? I think it's cool. Maybe you're like, nah, it's lame, but I think it's really cool. All right, last one, guys. Check it out. I wanted to put an extra question and call it laziness, call it whatever you want. I was like, I don't want to type brand new numbers. All I did was I toggled your A, X, and Y. It was -4, 7, and I'm like, 7, -4. We're good. So sorry, I was typing these notes out this morning, and my creative juices just ran out, and I just said, you know what? Let me just switch. All right. Anyways, here we go. This is the angle of standard position. Again, here's my grid. 7, -4. I'm in quadrant 4. So now if you do arctan, I bet you it will give you the right answer, but negative angle, so you'd have to do plus 360. So let's not do that. We can just do, this is 7. Oh, wait, yeah, that's 7. This is -4. If you wanted to find the hypotenuse, you can. The angle they're talking about is this angle. That's the angle they're talking about, see, because it's between 0 and 360. So we're going to find the reference angle, like before. So theta r is equal to arctan. Every time you're finding a reference, no negatives, so 4 over 7. So let's do that real quick. Arctan, go to Desmos. Notice the other one was 7/4, so I got to clear all here. So I'm going to go arctan of 4 over 7. And there it is, 29.74. So I'm gonna put that A equals that. And then I'm gonna start a new line. I'm gonna go 360 minus A. So there it is, 330.255. 330.3. Theta, oh, let me first, this was, I already forgot it, 29 point something. And then go back to red, 330 point, was it 330.3? And what was this, 29.7?
Yes.
Okay. So if I would have done arctan, I would have had to have had 180 twice because I'm in quadrant 4. It would have given me the correct answer. It would have given me negative 29.7. So let's try it out really quick. So if I would have done it on Desmos with a negative on the inside, so let me clear this one. So look, check it out, guys. Here's my negative. And yeah, negative 29.74, that is correct. That's in quadrant 4, but the angle has to be positive. So I'm gonna add 180 to it. Well, actually add 360, but you'll see. Add 180 first. Oh, I gotta put A first. A plus 180. And then you're like, it can't be that answer because that answer is in quadrant 2. So then let me add another 180. So let's put it in parentheses 2. And there it is, 330.3. See? It all makes sense, guys. At least I hope it does.